Ladies and gentlemen, I'd like to welcome you all to the Potomac Institute for Policy Studies. However, it looks like the room is full of friends and colleagues and associates, and thank you all for coming. And I think you'll be very happy with today's presentation. For the camera and for our publication and for the few people in the room who haven't been here before, the Potomac Institute for Policy Studies is a not-for-profit organization here in the D.C. area that focuses on science and technology policy, how we should be deriving a lot of our policy based upon good science, a good understanding of the technology, and make our political decisions, our policy decisions based upon rationality and science. Science and technology policy is also helping our policymakers decide how to help fund, direct, and help guide science, the exploitation, the development of science and technology policy for the good of mankind. Here at the Potomac Institute, we like to think that we're involved in that discussion, helping to identify issues that can be analyzed and develop policy recommendations for members of Congress and the administration that help guide the policy. And to the extent that we're successful at that, it's because at forums like this, we're able to often bring together scientists and policymakers to discuss the pressing issues of our time and discuss how science and technology can inform policy here in the nation's capital. For quite some time, we've been involved in, or at least thinking quite a bit about, as has most people in the science and technology policy world, about the effects and implications of global climate change. There's still lots of debate about what causes it, but I believe there isn't much rational debate left about the fact of global climate change. And as it comes upon us, the implications of that for mankind, for our existence, for our planet, are things that need to be considered with all seriousness and due haste. So it's with great pleasure that we have with us today a scientist studying these issues, studying them by being involved, going to the places that are affected and talking to the people affected and working through the issues that global climate change would have on their lives and therefore potentially on all of our lives. So this is, I think, the third seminar we've had over the past several years on global climate change and its impacts on not really national security, on global security, and I'm absolutely sure that it won't be the last. I'm going to turn the introduction of our speaker over to our Chief of Staff, Catherine Schuler-Worster, who is also a member of the Center for Revolutionary Science Thought here at the Potomac Institute and involved in an awful lot of this analysis and recommendation to Congress. And she's been the Chief of Staff for a year now, and that's why the Potomac Institute has new spaces, is actually operating better because they took the reins away from me and gave them to her. Catherine.
Thank you all for being here. Dr. Victoria Keener is a research fellow at the East-West Center in Honolulu, and we're all very jealous that she gets to wake up and go to work in Honolulu every day. She is the lead principal investigator of the Pacific Regional Integrated Sciences and Assessments program, which is funded by NOAA. And she's going to tell us a little bit about the Pacific Islands Regional Climate Assessment Report, which is about to come out. And she's a dear friend. Thank you for being here, Victoria.
Hi, everyone. Thanks for inviting me here today. And Catherine, thank you for setting everything up. It's fairly thrilling to grow up with somebody and then be able to combine your worlds professionally as well. So I'm really glad that it worked out. As Catherine said, the grant that I'm on, my main grant in Hawaii, is a NOAA-funded grant called the Pacific RISA, or Regional Integrated Sciences and Assessments. And the purpose of that grant is really to take an integrated look, not only horizontally but vertically across decision-making scales. So horizontally, in that we integrate both physical and social sciences to address and solve problems about regional climate change in the Pacific Islands, and vertically in that we're very use-inspired. We do use-inspired science, so we work with stakeholders and decision makers in the region at every step of the process. We co-develop our research plans, so instead of doing science in a room and then coming down with peer-reviewed journal articles and hoping that they get out there, we're really working with people at every step of the process to ensure that the information that we get to them is usable, that it's things that they want to use, that they have the ability to use it, that it fits within their mandate, and that we have a relationship with them where they trust what kind of information we're getting to them. So that's kind of a little bit about our grant. Under that, I work within the East-West Center, as Catherine said, where I'm a research fellow. The East-West Center is an NGO, a research center that does both education, research, seminars, a lot of journalist exchange programs. It was founded to really be a link between the mainland United States and Asia and the Pacific. The work that I'm going to be talking about today is mainly on the Pacific Islands Regional Climate Assessment, which was the regional technical input to the forthcoming National Climate Assessment, which the White House will be releasing in March of 2014. So, the key issues that I'm going to address in this talk are several-fold, so look for these themes reappearing throughout the talk. The first one is disaster preparedness. In the Pacific Islands region, there are a lot of natural disasters which occur, and in many cases, Pacific Command is responsible for addressing a lot of the disasters that happen. So, for example, there was a very large drought in the Marshall Islands in the beginning of this year. Pacific Command is responsible for getting them food and water. It was declared a national disaster or a disaster area, and Obama had sent relief and such. But these kinds of issues are going to pop up more and more as sea level rises, and especially in the Western Pacific, where global sea levels are actually highest. In terms of national security, Pacific Command has the largest purview of all the command areas, and it's centered in Honolulu. So they have a very large area, although it is mostly ocean. They have a wide variety of both human and environmental security issues to look at, including food and water security. So the impacts of climate change on food and water security throughout the region are going to be several-fold, not only from things like precipitation patterns changing and sea levels rising, so not only the wave overwash salting over the land, but coming up from underneath, reducing those freshwater tables that people use to get fresh water to drink and to irrigate their crops. And finally, in terms of immigration and its effect on national security, many people are not aware that we have a lot of freely associated states in the Pacific. So, for example, I'll go through this later, but the implications for climate change on where those people will go and what it means when their lands are no longer inhabitable, what it means for their statehood, what it means legally for them, and in many cases as people come to Hawaii, which only makes sense both culturally and in terms of island culture. But we're going to be having a lot of climate migrants in the future. So as I said, the work that we're doing here is for the National Climate Assessment. The National Climate Assessment was mandated by the U.S. Global Change Research Act of 1990. And what that means, in the act they said that every 4 years they wanted there to be a report to Congress which summarized climate science investments in the United States and incorporated them really into a larger context to identify vulnerabilities. So looking at mitigation and adaptation options, economic opportunities, gaps in assessments and research, and really integrating both from an academic and an interagency viewpoint different issues that are coming up. As it's happened so far, because of politics and funding, there have been 2 national climate assessments since 1990, one in 2001 and one in 2007. The one that's going to be coming out in March of 2014 is actually the largest one that they've tried to do to date, and the one that they've really tried to make it decision makers at a wide scale. And really the overarching idea of this is they want to help people prioritize their federal science investments in climate change. So our regional input was the Pacific Islands Regional Climate Assessment, and this is a freely downloadable report. I'll give you the address for it later. It came out at the beginning of this year, actually at the end of 2012, and it was about a 200-page document. And what it does is provide context as a regional technical input to about a 10-page chapter that will be in the National Climate Assessment on Hawaii and U.S.-affiliated Pacific Islands. So the aims of the PIRCA were to assess the current state of knowledge in the region, both impacts and adaptive capacity, to support decision-making both regionally and globally. The participants that were involved were government agencies, non-government agencies, businesses, community groups, watershed partnerships, NGOs, academia, so a wide variety of different groups. The activities that were conducted included dialogues, workshops, literature reviews. We got bunches of scientists together from the region in the same room to come to consensus on the key trends and the key problems that they saw for the region in terms of climate science. And the products, as I said, included our technical report, a forthcoming National Climate Assessment chapter, and 2 forums which we held that brought the communities together, one in Honolulu in December and another one in Suva, Fiji, which brought together our international partners in January of 2013. So the PIRCA in context, what we did was split it into 3 main technical areas. The first was freshwater sustainability and drought, coastal inundation and sea level rise, and aquatic and terrestrial ecosystems. So around these 3 technical areas, we had scientists convene and really come to consensus on those key trends in different workshops. Under these overarching bubbles of looking at the impacts of the science on agriculture, different sectors such as agriculture or business and infrastructure, socioeconomic resources, and also the adaptive capacity. And that includes not only the opportunities, but also the constraints that are on different islands and different countries that are involved, policy and government limitations, institutions that are involved, and the networks that are being formed, and the impacts on communities. As I said, we had quite a lot of participation. We had more than 100 collaborators to the report, and as you can see from this rainbow of logos across the screen, there were quite a few main organizational groups, including NOAA, the University of Hawaii, USGS, some other government partners, the U.S. Fish and Wildlife Service, as well as academics and nonprofits, and for example, WARI, our partners at Guam, the University of Guam. So just a little bit of background on the region. A lot of people aren't used to seeing a Pacific-centered map. Usually, if you see a map of the world, the edge is cut off somewhere around Hawaii. So you really don't get a good picture of exactly how large the Pacific Ocean is. And it's very large. What we did was split it into 3 climatological main regions. So we had the central North Pacific, which in our case is just the Hawaiian archipelago, the western North Pacific, which includes the Commonwealth of the Northern Mariana Islands, Guam, the Republic of Palau, the Federated States of Micronesia, and the Republic of the Marshall Islands, the remote islands, and finally in the south, American Samoa is our only U.S.-affiliated island down there. And just to give you an idea of exactly how big the region is, what we've done is show you how if we fit the United States in there, it doesn't cover just 1 United States, not 2 United States, but about 3 to get across that big ocean. The first thing I did was I scaled down a picture of the moon and put it there. And it's a couple moons across too, but then I just thought maybe people would think the moon was small, so I decided to go with the United States instead. Just a little bit about the demographics of the region. In terms of U.S. holdings, there are more than 2,000 islands scattered across millions of square miles of ocean. There are about 2 million inhabitants over all of those islands. Interestingly, the islands comprise more than half of the United States' exclusive economic zone, so it's a very important ocean region. There are diverse cultures, at least 20 languages are spoken. And as I said before, there's a large U.S. military presence, not only at Pacific Command in Honolulu, but also in Guam, where there's planning to be a large military buildup as they move people over from Okinawa in the next couple of years, probably. And in Kwajalein, where there is a missile defense system, which is in the Republic of the Marshall Islands. There's also, of course, a military history in the Marshall Islands with Bikini Atoll and the nuclear testing. So now I'm going to get into a little bit of the science and just show you some of the main trends in terms of climate variables that we've been tracking throughout the region. And one of the strengths of this is that when a lot of people debate climate science, they really get worked up about projections into the future, what those are based on, the politics behind it, and the implications. And what we're not doing, or what I'm not going to show you in these are projections, what I'm going to show you are trends, so data that we've seen over the past centuries about things that are going on. So whether or not you believe in climate change or in what's causing it, this is the data on what we're seeing. So now that I've told you everything about how unique the Pacific Islands is, I also wanted to show you this diagram and talk about some of the things that we share with the rest of the world in terms of climate indicators. So for example, all over the world and in Hawaii and the Pacific Islands, carbon dioxide concentrations in the atmosphere are rising. Mauna Loa on the Big Island of Hawaii actually has the longest running record of atmospheric carbon dioxide in the world. It's, in my opinion, a priceless data source, one that is kept alive by the tireless efforts of a couple scientists who are always stringing together funding from different sources, trying to keep that record continuous so we have eyes into what the atmosphere is doing. All around the world, globally, the surface air temperature is rising. Across the region, we're also seeing surface air temperatures rising throughout the Pacific. Also things like extreme events changing. Now, I'm not saying extreme events are just increasing. You may have seen there was an op-ed in the Washington Post just a couple of days ago that I saw by Bjorn Lornborg about the recent NOAA report talking about extreme events and event attribution to climate change. So what he was saying is that, and what is true, is that some extreme events are going to go up and some extreme events are going to go down, really. It only makes sense. And we're seeing that in the Pacific region as well. Some of the things that are more specific to the islands include base flow in our streams, which is decreasing. Base flow refers to the groundwater component of stream flow. So no matter what people are taking from the surface water, you can still see that trend that's undisturbed in the groundwater. And really for a state like Hawaii that gets 99% of its potable water from groundwater, this has severe implications for the future, even without considering climate change in terms of water sustainability. We're also seeing changing habitats and species distributions. As it warms further up or down the mountain, the species are moving to escape that difference in temperature. And the carbonate chemistry in our reefs is changing, affecting the reef ecosystems and the coral life there. So in terms of our freshwater resources and the findings that we have there, when the researchers came together to really discuss their key messages, what they wanted to convey was that Pacific Islands have limited and fragile freshwater resources. And you can imagine this is because they're islands. They're much smaller than continents and much more sensitive to stresses to that system. So for example, in this cross-section of an island ecosystem, or an island hydrological system, what happens when the rain hits the top of the island, it sinks down like a sponge through that. Some of it runs off and some of it sinks down through that volcanic rock and creates a freshwater lens underlying the island. This is separated by a thin layer of brackish water, so that really that freshwater lens is separated by a very small barrier from salt water from the ocean. And you can imagine as we drill more wells, or as there's less precipitation that seeps down through those mountains, that freshwater lens varies. It gets thinner and thicker. So as we pump more out, we have more of a risk of getting saltwater intrusion into our irrigation areas and our potable water supply. Another thing that makes climate science difficult in the Pacific region is that we have very high natural climate variability. So this doesn't refer to global warming. This refers to natural systems such as the El Nino Southern Oscillation. You may be familiar with climate phenomena and oscillations such as the El Nino or La Nina. And this also refers to the Pacific Decadal Oscillation, which has a high influence in the region. And what that really does is, what we're looking for with global warming systems is a long-term trend over time, and the climate variability puts noise into that system, making it more difficult to filter out that long-term trend. Finally, something that all of the scientists across all the different fields came forward to say was that in this time where we're experiencing more rapid environmental change than we've ever seen before, getting data and basic monitoring on our environmental variables is more important than ever. We need eyes from the past and in the present to be able to predict things into the future. And a lot of federal funding for monitoring is being cut at the point where we need it the most. So I said that air temperature across the region was rising, both all over the Pacific, the north, the south, the west. Average, minimum, and maximum air temperatures have been rising. We have a record in Hawaii over the last century or so that shows the rise, and in Micronesia and American Samoa about the last 60 years or so. And really what this shows is in Hawaii, these stations are showing that temperature rise has accelerated in the past 30 years or so. So those are the red bubbles on the graph. You're seeing that last 30 years of data really showing an increased rate in temperature rise. What we're also seeing is that when we separate it out into low elevation and high elevation stations, so low elevation is in the middle and high elevation is at the bottom, we're seeing a more rapid rise in air temperature at high elevation stations that are about half a mile above sea level or so. And really what is important about that is some of our most fragile and native ecosystems are actually at the high elevations in Hawaii. So where we have the most endemic species, where we have the most fragile and protected forests that in turn feed the water to the rest of the island, are under the most pressure from rising air temperatures. We also see precipitation and drought patterns changing across the region. This is data from Micronesia, and it's from 1950 to 2010 showing trends in precipitation. And really what this is showing is that in East Micronesia, the trends are showing that islands have been getting significantly drier over the past 60 years. The size of the bubble and the color, the more red it is a bigger drying trend. And in West Micronesia, we don't really see much of a trend so far. There's no trend, or it's getting insignificantly wetter. But what we're also seeing, as I said previously, is we've had this really bad drought in the northern atolls in the Republic of the Marshall Islands beginning in 2013. And it's really playing out by, you can see these trends happening more and more. We're having to deliver more aid, more water. There's more issues with food security. Of course, it's very expensive to ship food and water out there. So we're going to see these trends continuing throughout the future. We also see these trends in Hawaii. In the past 30 years, annual precipitation across the entire state on average has decreased significantly. All Hawaiian islands have experienced greater numbers of consecutive dry days, so days in which it doesn't rain, which is a measure of drought in the islands, and fewer days of intense rainfall. So you may have heard when people talk about climate change impacts on extreme events, you may hear a lot that the storms are supposed to become more intense. So in our region, we're seeing that the storms are predicted to become more intense. However, we're going to get fewer of them. So that's kind of an interesting thing that we're seeing in Hawaii. What this figure does is overlay trends in the past of consecutive dry days, which are shown by the triangles. So increasing trends in drought, in dry days, are indicated by the large red triangles. And the color map that's overlaying it is actually a projection of looking into the future about what we're expecting to see at the end of the century in terms of drought risk. And for the Hawaiian Islands, in most cases, the leeward sides of many of the islands are expected to increase in drought risk. And there are very few areas indicated by the blue, mostly at the tops of the mountains on the windward sides, or Kauai in the very middle, the wettest place on Earth. Are there regions where drought risk is actually expected to decrease? As I mentioned previously, base flow in Hawaiian streams is also decreasing significantly. And again, base flow refers to that groundwater component of stream flow. This is a wonderful USGS research study, the Pacific Islands Water Research Center in Honolulu, that has looked at this amazing record we have of 100 years of stream flow data. And as a hydroclimatologist, I'll just tell you that it's extremely rare to have a stream flow record that long. For my dissertation, I was working with 25, 30 years of stream flow data, but we have this great record because there's actually a very long history of sugarcane agriculture. And the sugarcane farmers in Hawaii kept very good records. as sugarcane industry has decreased, we've been losing those stations, not only weather stations and climate stations, but stream flow gauges as well. And the USGS has not been able to recapture them all with adequate federal funding. So really these most important long-term records that can give us the best look into trends and into projections into the future are becoming less and less. But what this shows is on 8 out of 9 century-long long-term stream gauges in the Hawaiian Islands, base flow has decreased from 20 to 70% in the last century or so, which is very concerning. Something we've also all heard about is globally average sea level is rising. Since the 1990s, global average sea level rise has been about 0.13 inches per year, which may not sound like a lot or something to be concerned about until you realize that it's twice the estimated rate for the 20th century as a whole. Now what this figure is showing is for global average sea level rise is a range of projections on what they're expecting. So the lowest in blue down at about 0.2 meters and the highest at 2.0 meters. And this is out to 2100. So these climate model projections are for a 6 to 24 inch in global sea level average rise by the end of the century. This also has implications regionally because what we know is that sea level rise is non-uniform and non-steady. Although they talk about the global rate, everything rising, it's not equal everywhere. So this is actually data looking at sea level rise trends for the past 15 years or so globally. Red and orange warm colors on that map indicate the highest areas of sea level rise in the world. And something that should pop out at you right away is that although there are bits and pieces of red around that map, the Western Pacific has experienced the highest rates of sea level rise in the world in the past 15 years. And that's actually a natural trend. We're in a very strong trade wind period right now. And what that means is the trade winds are actually pushing the water naturally from the east to the west, and it's all piling up in the Western Pacific Ocean. So while we're in this regime of strong trade winds, the western islands, the atolls that are at most risk anyway because they're only a couple feet above sea level, are really getting the brunt of that impact. They're really being affected more than the rest of the world and the other islands. And really what this does is increase that stress on them because not only are they dealing with the global rise that's happening incrementally, but also this natural rise putting extra stress on them. So as I just said, increasing average sea level means more frequent extreme sea levels. So these sea level events that are extreme occur when high tides combine with non-tidal events such as a storm or a wave overwash event. What we see in this is that it not only affects things like coastal infrastructure, houses and military installations, but also ecosystems. So for example, on the Midway Islands are some of the largest populations of ground nesting birds like albatross. There was a king tide event in 2009 that wiped out about 40% of the breeding population of Blackfoot albatross on the islands. So really what we're seeing is that these increased coastal inundation events and risk into the future are going to threaten communities and wildlife, and this is only going to be getting worse. We also know that the distribution of regional coastal and pelagic fisheries is going to shift into the future. And for a region in which one of the main economic things to rely on is fisheries and fishing, both subsistence and trade, we know that this is going to have a huge impact. So what we see is not only changing ocean temperatures within the region, but that's going to affect the base of the food chain at the most basic level. So what we see on the right are projected changes in primary production. So again, that very base of the food chain, which is going to dictate where the large groups of fish go in the future. What we know are that some countries are going to prosper from these shifts and some are going to suffer, be impacted negatively. But we don't know exactly where those fish are going to go yet. Models are showing that there are going to be increased primary production in the central Pacific and then decreased in the northern and southern Pacific. But we don't know exactly what it means yet, so this is a question that everyone's very eager, especially a lot of the subsistence fisheries and small islands in the west that they're going to be tracking very slowly. So again, this projection is for the end of this century.
I'm sorry, going back to the
Yes.
earlier chart, I'll show my ignorance. What does pelagic mean?
Open water. So instead of near shore, but out in the open ocean.
Never heard of it.
Sorry about that. This is a sobering slide, one that always gets me down every time I show it. So the threats to coral reefs within the region include both rises in ocean temperature, which cause bleaching events, and increased acidification, which results from increased carbon dioxide in the atmosphere and impacts how corals can build their skeletons. So by 2050, it's predicted that many coral reefs may bleach on an annual basis. On the top, this map is showing annual reef bleaching projected in the 2030s. Of course, the oranges and reds are the percentages. That dark red that you see at the bottom in the 2050s projection is showing that most of the reef regions in the world should be bleaching annually by about 2050. And that's not to say that reef ecosystems can't recover from bleaching events, but if it happens every single year, it severely inhibits their resiliency. So these are going to be impacted more and more into the future, and we are seeing that. And these projections, in case you're interested, are based on the Intergovernmental Panel on Climate Change's A1B scenario, which is basically the business as usual, what we're doing now, if we keep doing it into the future. This is what's projected for coral reefs. Now I'm going to get into back out of the science and bring it back down to a more general level, the implications and really the implications that climate change has for the Pacific community and for the world, really, in these cross-cutting issues. So as we talked about at first, disaster preparedness for the region is a huge issue. In the Pacific region, it's of course very spread out. There are a lot of issues that are by no means unique to the region, but but strongly affect our ability to address disasters. That includes things like backfill, staff backfill. A lot of times on U.S. affiliated islands, someone will leave a position and there's no one to take it over. No one's trained. It'll stay open for years and years, and this has a lot of implications for disaster management. There's also high turnover. There are not a lot of opportunities. People leave. There's not a lot of institutional knowledge that gets passed on. And also within the region, contextual and cultural competencies vary. Some kinds of efforts that are going on in the region to help with this are climate-based early warning systems to help predict things like infectious diseases, which are expected to change under different climate conditions in the future, and food and water conditions, food and water shortages in the future, which I already mentioned, in terms of drought impacts on a lot of the atolls, especially, and getting mobile RO units to desalinate water, for example, out to people who need it. And really one of the main things that we find helps is to increase awareness of disasters, to increase communication both across agencies, across states, across countries, and for people to really have an environment in which they can collaborate together and be rewarded for that. So interagency collaboration, in which cross-coordination is looked upon as a good thing. We also know that climate change is going to impact the security environment and the roles and strategy and infrastructure for the military. I've just listed here a couple of the coastal assets of the military that are vulnerable to climate change impacts in the Pacific. So this includes things like training and testing lands, which are mainly coastal. Of course, on an island, you could argue that everything is coastal. Navigation channels, piers, docks, roads, bridges, important communication and data centers for the military, office and residential buildings for servicemen, fuel tanks, distribution lines, water treatment and supply lines, both for the military and for delivering to vulnerable populations in disaster times, electricity systems, many of which are underwater, shoreline buffers, barrier islands, coastal wetlands, all these in terms of ecosystem services, and on a larger level, habitat for protected species. The military is starting to look at a lot of things such as technology performance vulnerabilities and doing risk assessments in terms of climate change impacts on their military infrastructure. For example, the SERDIP program, the DoD Strategic Environmental Research Defense Program, I believe that's the acronym, has just funded us to do a several-year project beginning in February of 2014, looking at the vulnerability of military infrastructure on the island of Guam to climate change impacts on their freshwater resources, especially considering the buildup. So we'll be starting that. So the military is taking an active interest. But also in terms of regional conflict with changes in food and water security and the migration of peoples from lower islands to high islands from different countries all over the region. And here on the right is just a picture of a test missile being fired from Kwajalein Atoll. And I think the average elevation of Kwajalein is 3 or 4 feet above sea level. So obviously that missile system is highly vulnerable. There's also, as I've mentioned, food and water security impacts for the people across the region. So drought and flooding both destroy crops and impact freshwater supplies. So that picture up on the top is a picture of a taro field in the state of Chuuk in the Federated States of Micronesia after a wave overwash event. And really what they see is with that, the narrowing of the freshwater lens and the rising of the ocean water coupled with these wave overwash events, they're doubly getting hammered by these impacts to their the agriculture on the island, and they don't have that much land to begin with, so they need to protect it. And when we talk to people about the kinds of decisions they're making, the most basic questions they always ask is, in the future, how much water will be available, where is it going to be, and when is it going to be there? So we've been working with, for example, on Maui, we have a project working with the water department, city planners, the county of Maui planners, and the state commission on water resources to really look at impacts of climate change on security of fresh water in the future. And what we've been doing so far is looking at that under a scenarios situation. So using different climate scenarios in the future to look at different management and climate impacts on freshwater resources. So really, one of the main questions we want to know as well is are our policies adequately adaptive for managing freshwater into the future under climate change conditions? And in Hawaii, some of the work we've shown is that we do have a very adaptive water law base, but it's not always put into practice adequately or maintained. So we've been looking at ways to deal with making it more responsive to climate issues. One of the other things is that climate change will force human migration. An interesting thing about climate migrants, which is now the preferred term for refugees from climate change, is that there's no single legal entity that covers climate migrants in the world. So for example, in a violent conflict, say from a war, there are international rules that govern what type of rights people get when they leave their country. However, for climate migrants, people that are forced to leave their countries because the entire coastline is no longer inhabitable, there are no international laws that govern that, and it's a big problem. We're already seeing populations of people being displaced, having to basically work on their own. For example, there are Carteret Islanders in the South Pacific who have been displaced from their islands because of they can't grow anything. It's salted at this point, and it's uninhabitable. So they've been migrating over the past few years to the main islands of Papua New Guinea. And basically, they get in trucks and go around begging from village to village to be accepted into those communities, and they're getting no support from their governments or the international community on how to do that. One thing you can see in the second bullet, projections of global climate migrants in 2050 range from 25 million to 1 billion. Obviously, that's a huge number of people, but what it also shows is that there's a huge range of uncertainty in that estimate, and there's a lot more work that needs to be done. Within the Pacific region, of course, the numbers are much smaller. There are much fewer people. Only a couple million are expected to be affected. I think it's up to 1.4 million that might be affected in terms of climate-induced migration. But it really shows the work that needs to be done. Now, one of the interesting things is that unlike many others in the world, the Pacific Islanders, many of them will not be able to migrate domestically. So for example, if you're in Florida and Miami, let's say, gets overrun and is no longer inhabitable, you just move up to Tampa or move up to Gainesville, and there's some place you can go even within your state that's still fine. But if your entire country is only a few feet above sea level in a lot of these atoll nations, what does that mean for you? One of the interesting things about the Compact of Free Association, which a lot of our U.S. affiliated territories and states are under in the Pacific, is that they do have an American passport and they have the right to come and live and work in the United States with their families. But the compact expires in 2023, I believe, and the government has not indicated whether they want to renew it yet. I'd say they probably will, because it gives us military rights to the exclusive economic zones. But we give them aid, and in turn we get military rights to those waters. So a question is, if your entire country goes under, does your government still have right to those fishing rights if you don't have any land to live on? Do you still have a government that's independent? And these are questions that have been bandied about in the academic world but have not been answered on a meaningful level and have been thrown around in the literature since at least the 2001 IPCC report. I also want to come back to this call that we've heard from all of the scientists and all of the planners and policymakers within the region, are that we need the data and observations for adaptation and management in this time of rapid change. The Pacific Islands overall has experienced a decrease in climate monitoring stations, and that not only includes things such as precipitation, rain gauges, weather systems, stream gauges, but also things like buoys. One thing I found out in the last tsunami alert in Hawaii was that when there was an earthquake and a potential tsunami coming from Alaska, we had no way of knowing what happens between Alaska by the time that wave hits Hawaii. There are no buoys that give us information on that between there. So the tropical observing system has been in decline for a while, but also has not ever been comprehensive in the first place. And really, as I said before, our ability to assess future climate change in meaningful detail is at risk without this data, to both see what's going on now and calibrate models to project in the future. And this figure shows the number of stream gauges maintained by the USGS in Honolulu from about 1910 to 2010. So with the rise of sugarcane agriculture in Hawaii, we saw a lot more. And then in the the late 1960s, early 1970s, we really started seeing this drop off in available stream gauges. So at a peak of about 200 gauges mid-century, and now we're down to fewer than 50 stations across the state. In other Pacific islands with streams, we see a very similar trend, except they had much less data to begin with. And of course, these are very complicated, well thought out monitoring systems that aren't cheap to install, but they do give us wonderful data. And as I kind of started with, one of the take-home messages that we've found, not only for the National Climate Assessment, but in our Pacific RISA work, and also in our work with the East-West Center and the regional organizations, is that really to make a difference in any of this, we need partnerships between scientists and decision makers at all levels of the decision-making process, whether it's at the community level, the regional level, the global level. We need it all. And this is because the Pacific Islands really face these very multidimensional problems, not to say that other places don't, but it's very important in our region to realize that neither science nor management alone can adequately address climate change in the region. One of our main resources has been Ms. Olai Uladong, who's the lead negotiator for the UNFCCC, the Framework on Climate Change, representing the Alliance of Small Island States, or AOSIS, and she's been a tireless advocate. And she's really a link that we have to the international level of Pacific Islands and climate. Finally, one of our new collaborative efforts that sprung out of some of this work is a new regional environmental security group called the Climate, Environment, and Security in the Asia-Pacific Region Working Group, which convened after the climate assessment work was done, as we saw a gap in our own research. Discussion topics so far, it's fairly new, have included water security and drought, military infrastructure, disaster response and early warning, really focusing on drought so far. But we've been getting more members into it, and so far we have people from Pacific Command represented. Of course, Admiral Locklear, the Chief of Pacific Command, back in March of this year, I believe, said that climate change was the greatest threat to the Asia-Pacific region in the future. And then North Korea happened, but hopefully he'll be back there. Also representatives from East-West Center, where I am, the Center for Asia and Pacific Security Studies, which is a DoD research group in Hawaii, and many state and federal agencies as well. So we see this type of collaborative working group as some way in which we can really extend our reach into the environmental security and human security world. So as a summary for people who may be interested in policy, policymakers, what to do, there are two main take-home messages that we got from representatives in the region, both with resource allocation and with leadership. So in terms of resource allocation, our main messages were to help build climate resilient communities. And this means not putting off actions that will only help your community today, waiting for better information to come out later. So having uncertainty in scientific information is no excuse not to take action now. I'll just hammer it home again: to support monitoring, rebuild, upgrade, expand the network of systems that we already have. Something that scientists in our group like to say is that monitoring is not sexy science. People do not like to fund it. It doesn't have immediate payoffs, but it's an extremely necessary thing for all research. And again, to support integrated research that's problem-focused, works with people making decisions on the ground, and is iterative and flexible and adaptive. So ones like my program, in which physical scientists and social scientists work together on problems, are just that kind of integrated research that can really help things. And then in terms of leadership, things that we've seen that are very helpful within the region are partnerships that create creative solutions, and the importance of having a champion. And this is a person that you can find within an organization that really has both the breadth of knowledge and the reach to make a difference. I think that most of our projects, if you don't find that champion within the group that you're working with, it's not going to go far. So cultivating that person, if they're not around, is also an option. So finally, if you want to download the PIRCA reports, which are freely available, and those are the 200-page assessment report we did, a series of case studies or regional stories about impacts on different sectors, or just an 8-page executive summary. Those are available at the website above. And the four main editors, lead editors of the report, feel free to contact any of us for any more information, statistics, papers, citations, whatever you're interested in knowing. And with that, I will wrap up and open up to questions.
Victoria, could you tell us a little bit about your team, the project organization? How many
The
people
RISA?
do you have? Do you do most of your own data gathering?
Yeah, so the question was to tell a little bit about the Pacific RISA team and who we work with, and how big it is, and the type of data we work with. So our team, the core PIs, I'm the lead, and I'm hydrometallurgy and engineering. And our two main collaborators are the Water Resources Research Center at the University of Hawaii, which are hydrologists, and the International Pacific Research Center, also at University of Hawaii, who are climatologists, meteorologists. So the climate group does the global downscaling, which is taking global climate models, putting them at an island scale, so we can get regional and island level projections for the future. We then put those into water budgets for the islands and for specific groups to look at climate change impacts on water resources. One of my colleagues who was here with me earlier in the week but had to go back to RAND in Pittsburgh is Melissa Finucane, and she's a decision scientist, so her background is actually in psychology. She's one of the social scientists, and we have another community psychologist on our group. We partner heavily in the region with, for example, the USGS. We get a lot of our data from the USGS. The Pacific Islands Climate Change Cooperative, which is a landscape conservation cooperative, and LCC, which is a DOI-funded center. And the DOI also has new climate science centers, which they're rolling out in all of the regions of the United States. In terms of the RISA program generally, NOAA has 11 RISAs, which are, of course, regionally based, scattered around the United States. There isn't one for this region. But there is one for the urban Northeast, which is centered at Columbia University, and one in the Southeast, which is centered at Florida, University of Florida, and another one in the Carolinas. as well.
Can you talk a little bit about what some of those islands are doing to adapt now?
You would think this was a plant because we're friends, but I actually also have this slide of examples of regional actions, just in case. I promise we didn't talk about this beforehand. So the question was, what are small islands doing? What are some things that they're doing to start adapting to climate impacts? So these regional actions, so for example, in Fiji, I know a group that is translating just climate change terms, which often don't exist in a lot of the other languages around the region, into understandable things so that people who live there have words to talk about what they're seeing and how to adapt. A group called the Micronesian Conservation Trust, or MCT, has a project that they call the Climate Change Flip Chart, which is really a community-based thing where they go and talk to villages, they talk to people where they map out the decisions that people are making and put climate cycles on top of that. They map out when the elders have seen droughts and floods in the past and how that corresponds to the changing climate systems. Two organizations in the region are Scopic, which is Australian, I believe, and PIAC, which is from National Weather Service in Honolulu. And those are monthly conference calls of all local meteorological service directors, which is actually, I said one of the main things to work on is communication. It's very unique to have these high-level directors from Met Services call in once a month and talk about what they're seeing across such a vast region like the Pacific, but they talk about the precipitation trends, the sea level trends, things like that, and they compare it and validate it across the region. So these calls are actually extremely unique and interesting. There have been climate change field schools all throughout the South Pacific. For example, in Vanuatu, they've done a lot with honeybee management under climate change conditions and traditional environmental knowledge, or TEK, so talking to people, finding out what they recognize from the past and how they can incorporate that into adaptation in the future. Other things, infrastructure in Hawaii, they used climate information to redo landfill construction. In Chuuk and FSM, they're raising the airport runway based on projections of sea level rise, doing lots of sea level rise modeling and how it's going to affect holdings on a lot of the islands. There's seasonal predictions that are being made. And in Hawaii, one of the big things was a climate change adaptation bill was passed last year, which is mandating that agencies start taking climate change into account when they do their planning.
So, hi, I'm Craig Childers.
Hi.
Very early on in your presentation, you showed the freshwater, the stream base flow data monitoring centers, and said that you had 200 of them when the sugar industry was at its peak, and it's now down to 50. And wouldn't we like more? So, assuming for a second, just let's assume that that's a good thing.
That the decrease is a good thing?
No, one, what does it cost? Two, given that the federal government, good or bad, is decreasing its funding, what are the impacted locals doing to make up the difference?
So the question is on the stream gauge network that's decreasing in Hawaii and the other Pacific islands. How much does a USGS stream gauge cost, and what are locals doing to address the decrease in gauging given federal funding constraints? So first of all, it's a cost share program to begin with. So the USGS maintains and collects all the data, but the initial setup is a cost share. And I think it's about $40,000 per partner to put in one stream gauge. And that pays for all the monitoring into the future. Now, in terms of, which really seems like a drop in the bucket for in terms of some of the things that we're spending money on, but in terms of what people are doing on islands to make up for that is, it in terms of measuring stream flow, it does seem expensive to a lot of people, especially if they don't have the money to get that level of gauging in. So people have been doing different methods of improvising measuring flow. The problem with that is that it's not directly comparable to USGS records because it's done in a different way, it's done in a different time scale, so a lot of the, and it's done in different locations. So they do create new records, but they're not nearly as well maintained or well set up, and they're not comparable with the longer records in many cases.
On the follow-on question to your question there, is the kind of a two-part question. Does USGS see the need and requirement to increase stream monitoring in Hawaii? And if they do, have they been budgeting for it or not?
The question is, has the USGS seen the need to increase stream monitoring in Hawaii, and are they budgeting for it? The answer to both of those questions is yes. They have been, but they've been being cut drastically.
You said on your earlier slides that the policy recommendation you're giving is climate-resistant communities or climate-resilient communities. The EPA announced today regulations on carbon dioxide for coal in coal-producing climates. Are you basically saying that it's too late to really cut down on the impact of climate change with recommendations, or are you still saying that we should try and reduce what might be causing climate change, as well as also begin adapting to the changes that are happening?
Very good question. So the question there was, is it too late for mitigation? Are we dealing with impacts and the only thing left to do is adapt in a lot of these communities? So in terms of encouraging climate resilient communities, we're saying that if it's a win-win situation, if you're making things better off in a specific community while simultaneously adapting for future climate conditions, it's a no-brainer. You should go in that route. In the island community, so for example, OLI and the UN FCCC, the small island states have been very vocal in not doing adaptation up until very recently because they wanted to push for mitigation funds. The amount of emissions that Pacific Islands contribute in terms of carbon dioxide, greenhouse gas emissions to the global climate system is minuscule. And yet many of these islands are getting some of the most severe impacts and will be getting a lot of the most severe impacts in the near future. So internationally and from the UN perspective, they've taken a tact of mitigation only. We don't even want to talk about adaptation. We're not even going to talk about the fact that someday we will not be able to live here. You're going to make it okay. This is your fault. But now at this point, they're really starting to talk about adaptation because it's too late.
That the migration of population and the implication of culture is impacting the island. And I think sometimes unintended consequences also happen with migration from the introduction of non-indigenous plants and other species that change the ecosystem of the island. So are you or are there other colleagues that are looking at the ecosystem holistically with the migration of the population?
With the migration of human population and the impacts on invasives.
Yeah.
So the question is, are there groups in the region that are looking holistically at the impacts of human migration on invasive species in the islands? And I don't know that there's one group that's looking at exactly that. Of course, in Hawaii, we have a very active USDA invasives program to try and keep as many plants and animals that don't belong in Hawaii out. Oahu is kind of a lost cause at this point. But many of the other islands are still pretty pristine and fairly good. In terms of how we split up different kinds of duties in our region, my group, the Pacific RISA, mainly deals with freshwater issues on climate. The PICSI, the Pacific Islands Climate Change Cooperative, which is a DOI initiative, mainly focused on ecosystems, and NOAA, the Coastal Services Center, something called the Pacific Climate Information System, or PACSIS, takes a lot of the sea level rise and coastal inundations issues. And of course, we're all on each other's committees, we go to each other's meetings, and so we talk very closely about what we're all doing and do work holistically. But in terms of human migration issues on invasives, I don't think there's been very much work done. Mm-hmm.
I think a lot of regional action and partnerships and conferences you guys have with other nations is very excellent. Are there any roadblocks you run into with other nations, unsupported groups, I guess?
Well, so the question is, in terms of collaboration in the region and internationally in the region, have there been roadblocks with other governments? Of course, a lot of the islands in the region and the governments are very keen to address climate change, and both from a funding issue and from a adaptation issue into the future. It's a very collaborative region, and I don't just say that without statistics to back it up. We actually have a social network project going on right now of climate change professionals within the U.S. affiliated islands. Our network had grown. We finished the survey a couple months ago. The network's over 1,000 people in the U.S. affiliated islands in Hawaii. And something that we found is that the connectivity, so what's that? 6 degrees of Kevin Bacon, if you've ever heard that. The way to get from one person to another across that network, the average node length is 3 people. So to get from any one person to any other person in that 1,000-person climate network is only a step of a chain of 3 people to get there, which is very high connectivity. So there are people talking to each other quite a bit, and we are getting the data to back that up. But in terms of governments, we had some trouble working in Fiji because of the military regime there. A lot of our NOAA colleagues were not able to travel there for the forum that we did, the climate forum. So yeah, there are some issues, but they do want to work together. In some cases, governments are just not allowed to interact with other governments. So. And the East-West Center, where I work, is actually, it's an NGO, so it was created also as a place of diplomacy and meeting, where, say, the U.S. could not meet with North Korea in the U.S., but they could meet at the East-West Center in a non-government building. Mm-hmm.
Part of this ideas about adaptation, you mentioned that there's no law protecting climate refugees. Thinking about that, because like our communities in the Marshall Islands, it wouldn't take much to make them non-existent. They can move a lot of people over. Thinking about that?
The question was, are there groups thinking about the international law implications of climate migrants? And there are groups, but it's academic. There was recently a conference last year at the Columbia University Law School on island refugees under climate change, and you know, a lot of working papers, but not a lot of action. One of the things that I always advocate for when I do talks on other islands and go visit other groups is, when I talk to students, is say, go into international law, you know, this is going to affect you in the very near future. Go study it now. And they nod their heads, so maybe in another 10 years we'll have a big flush of islander international lawyers dealing with it.
Have you, you want to go first? On recommendations for action coming out of this, your recommendations were, which are very standard and very appropriate. First set of recommendations: get more data, learn more. Absolutely. Collaboration and partnership, bring people in on your side to help. 2 very first good actions. Have you seen much on further actions, hard recommendations that says, here's an international policy that should be considered. Here's a program for mitigation that should be funded by the federal government. Specific other actions that the data and the collaboration will be needed to justify, but are there people thinking about what we're specifically actually going to need to do?
Yeah, so the question is in terms of very specific recommendations for both national and international actions and policies to support? Are there people working on that? And I think at the international level there really are. So for example, in the UN Framework on Climate Change, the UNFCCC, there are a lot of people working on that type of thing. A problem that we've come across, a barrier, if you will, is that a lot of our federal partners that we work very closely with in the region are not allowed to make policy recommendations at that level. So the NOAA people that we work with, for example, are you know, they can inform, but they can't recommend specific policies. So we have a lot of trouble getting very specific with our.
Do you have anybody in your current group of collaborators that is interested in doing that level of policy development and recommendation? Yeah, definitely. So in that climate and security working group that we've started, a lot of our collaborators at the Center for Asia Pacific Security Studies are interested in moving there with us. Now that's not my field of expertise, but we do have social scientists and economists and people working over there and with people at the East-West Center and across the area that are just starting to really look at these types of things. And of course on a regional, on a state level even, when it gets more specific, things like passing that climate adaptation bill last year was actually very big for Hawaii. So in terms of concrete actions, that was one. We just released a white paper that looks at, so our lawyer, oh, I forgot to mention our lawyer is part of our team. He's a research, our legal research professor at University of Hawaii, and he used to work with the Sea Grant Climate Center out there. We just hired one.
Oh, I actually love him. He's wonderful. But he wrote a white paper looking at, he basically wrote a series of tools that water managers could use under current Hawaii legislation. So without having to enact new laws, what kinds of adaptive capacities were there within current law to adapt to climate for freshwater resource sustainability in the future. And we've actually had 4 of the 12 tools become implemented into policy, which, and it was only released last year. So it's doing great.
Mike actually asked my question, but let me expand on it. You were kind of the canary in the mine shaft here. You're going to see effects before a lot of other people do. Mm-hmm. Is not the IPCC involved in getting lessons learned out of this?
The IPCC has its own problems, but I reviewed the Islands chapter, the new draft Islands chapter this year, and I haven't seen what's going into the final, but they're so careful about everything, and they don't want to make recommendations. You know, the science is the science, and the adaptation recommendations are just very general, like many of the things I've discussed.
This is actually, I think in our experience, whenever science and technology has a profound impact on society, it causes such political waves that people become leery and risk-adverse of making any recommendation or taking the necessary action seriously. So it's an area that we've been pushing on for a long time, that when we find science causing these types of social upheavals and people shying away from making recommendations to fix it, that might be a void in which we need to jump into. Because we do specific policy that's geared towards actually changing legislation. So the more specific, the more profoundly potential it has to do something good, the harder it is to develop to get something really specific.
Yeah, I very much agree.
Well, we should consider joining your partnership in some way, because this clearly is one of the most important issues facing the human race, and we're probably long past the point where we should be considering really profound, significant things that we can do to at least mitigate this event.
Yeah. Scientists don't step up. The only voices in the ring will be the political voices. Oh, please stop.
Yeah. Just as a note, we hear the canary in a coal mine metaphor a lot, talking about island population, And islanders do not like it. They do not like being called the canary in the coal mine. So I've heard bellwether a few times. As goes the Pacific, so goes the nation. But yeah, just FYI.
I'm going to have to follow on with this, or follow on or pile on, as the case may be. Mike also stole my question as well as yours. You're very good at that. Thank you. That's okay. You know, it foments other things. It's interesting because I'm going to ramble here for a moment, but I just came from another meeting at NIH, and your recommendation chart could have been my recommendation chart, where I briefed them, because it said many of the same things. And interestingly enough, your last word on that chart was the word that I left in. Who's the champion? You know, who is coming up with, and this is not rhetorical, anybody that has an answer, I'm all ears. You know, for example, you said it cost $40,000 to put in a data monitoring system. Well, you know, so you could build 200 of them for $8 million. I mean, as my good friend Keith Hall used to say, you know, that's not a rounding error, that's decimal dust. Yeah. I mean, it doesn't even exist. We lose more than that a day, an hour.
In terms of,
So,
you know,
and given the fact that you're a scientist, you got that part, and the rest of the people in the room out at NIH were all doctors and PhD scientists. You know, and I'm sorry, I'm just one of these inside the beltway weenies. And they all said, well, making recommendations to the Congress is not really our bag. I said, okay, so go get somebody. You know, go hire a lobbyist. Go hire Mike. You know, I mean,
We're not lobbyists.
But somebody that's well connected, that can whisper in the right ears at the right moment, say, you know, it sure would be nice if we had $8 million. And it's not a stretch to say, why don't we cost share that with the government of Hawaii? You know, by the by, why don't we cost share that with the governments of Micronesia, you know, whatever the acronym is there. But is anybody in your world trying to migrate this into the world where decisions, I mean, you said...
Well, that's why I'm here.
NOAA didn't want to make policy recommendations.
Yeah.
The thought was, then you don't have the right people in the room.
Yeah, that's exactly right.
Yeah, I mean, this has actually been a very eye-opening week for me. Hawaii is very far away from Washington, D.C., and even though I grew up here, you know, I left right after high school. I've been all over the place for school, but but just seeing how things work, you know, as I've been on the Hill earlier this week in our congressional briefing, dealing with all the staffers, it's very eye-opening, just seeing what the staffers write down. So I'm talking, and then, you know, I say something and they all scribble it down. I'm like, oh, I have to remember that. And you know, already seeing, you know, I've already gotten some pingbacks from staffers looking for statistics on the stream gauge thing, for example. So, you know, the East-West Center does have an office in D.C., and one of the purposes of its presence here is just because we are so far away to keep our work known in the region. But in terms of climate change, you know, they're not climate scientists. They're more Asia security people. So the voice is not strong here from our end. And
Well, consider partnering with somebody here in D.C. who lives the D.C. process.
Yeah, and I think that's an important thing to do in the future.
In this era of open data, you have a recommendation if you were to go to the Office of Science and Technology Policy. Is there government data that you wish you had that was open that would help to advance your research? And you know, could this group help to be a voice for that if there were things that could be made open?
So the question is on open data in government, and is there data that we don't have access to that we'd need to or we want to, and getting into that open data discussion. All of the data that was used in the Pacific Islands Regional Climate Assessment and any data that is used in the National Climate Assessment, which will be coming out early next year, is all open data. By requirement, it all has to be open. So there's been a lot of work done on making traceable accounts of that data and making it, they're building databases on the National Climate Assessment website to house all of this data that has not been available before. And a lot of it is because it's research data done by groups of scientists at specific universities who, it's proprietary data. In terms of things we haven't had access to, I've had a very difficult time getting any insurance information. and it's, on disasters, on money spent addressing disasters in Hawaii and the region, how insurance decisions are made. And I'm not an economist, and I need to talk to some economists about how to get that data, but I haven't had good luck with it. In terms of scientific data, there's nothing that I haven't had access to so far that I need, but I'm probably not the best person to ask on a lot of it, since I don't deal with all of it.
Thank you very much.
Thanks.
That's wonderful, wonderful presentation.
Thank you.
Appreciate it. Thank you all for coming. We're going to celebrate this wonderful talk and continue it, I hope, over some wine and cheese and cookies. So thanks again for coming.